Hello, good morning, friends. This is G.V. Shivakumar again. So, many of the instrumentation engineering graduates, they are asking actually, after seeing my videos actually, so they consider it as a negative thing. Say, whatever I explained is actually the industry environment, right? Actually, say, normally, in any core engineering, say we cannot have I can say very smooth or very kind approach. Actually, normally actually they are the persons working in machineries and actually with the more high pressures and alternatively ships and varying timings and so the management pressures and then interpersonal between the workers, right? Actually they are having a lot of conflicts, say due to some personal issues they are forced to work in, say for example some functions happening or taking place in their home, but they are unable to take leave or planned leave due to the due to the requirement that they need to be present during the shift. So for it is not a kind of IT kind of environment, right? Actually, say you can carry the laptop wherever you go and you can work from any time. Actually, whenever comfortable for you. So those kind of activities is not possible in real manufacturing scenario. So that is what actually many constraints. Not only the taking leave or say actually those who are working in core engineering. They are more experienced. Workers are more experienced than you. You are just completed engineering course BE or ME. So that actually with that experience actually or the education you cannot completely engage in complete maintenance or complete troubleshooting of equipments. Actually there actually it is not like IT. You can read and work on coding or kind of SAP kind of activity is not possible, right? Actually there you need to work in a field level work. Say a lot of logics are available. So they are calling us interlocks and say a lot of for maintaining valves, motors, compressors, air vents. So lot of internal troubleshooting incidents will happen. So you cannot gain all these things by reading a book. Actually you need to deeply dive into that, and then actually you need to learn from the worker and from your senior. So actually nobody will give the spoon feedback, right? Actually spoon feeding nobody will give. So you need to face a lot of very hard environments and everything. Hope you are understanding my words, right? Actually see a lot of conflicts, lot of politics are available there. Actually in that actually you need to learn all the maintenance or troubleshooting experiences or skills or methods. From where actually you can able to they are expecting you to work individually during your shift, and so that is a big challenge. Actually say the method of learning or method of syllabus in engineering B or BTech will not be enough or will not be sufficient to work in real time industry experience, where industry experience mainly it's a practical kind of thing. You need to learn everything practical, how to measure a voltage, how to measure ampere, how without tripping the unit, how you measure the particular voltage and everything. So many things can happen. Actually my friend once were when measuring the voltage, actually from the control room they are saying actually they are unable to get the close feedback of the valve. So when he's trying to do that, actually actually the valve is in open status, and actually say when he measures the voltage, actually that created a short, and automatically it will immediately close the valve, and then successfully that is so called interlocks. Say a particular mainstream valve is closed, then actually the next actually the fuel valve will close. Like that lot of logics or interlocks are available. So it will trip one after the other. Say after the mainstream valve close, actually the boiler will trip, and then boiler to turbine trip, turbine to turbo generator TG, right? Actually, generator motor or generator transformer trip, everything will happen. So these are loss to the unit. Say in case of power plant, actually you can say per hour, actually you will lose a lot of crores of money, right? Say, I mean, megawatt, actually, lot of megawatt loss and again results in lot of money or financial loss is there. So the management will question a lot of things, and next day actually he will be questioned, right? So that is what actually the problem is. Actually, you need to learn everything very deeply to avoid these problems. So this is a big challenge here. That is what I told. Otherwise, actually, instrumentation is a very good subject. It is no doubt in that. So many people are asking me actually, um, say, what is the future of instrumentation, electronics and instrumentation, or instrumentation and control, IC engineering, right? So in power plants. So I decided to create one video on the instrumentation side from the power plant aspect. Mainly in power plant we have three main branches: mechanical, and then electrical, and then instrumentation. So mechanical, without mechanical you cannot actually say erect a plant. And for operating any machineries or valves or compressors or electrical motors, vanes, fans, everything, we need electricity, right? Actually, so the electrical department is very important. Where transformers, I mean, mainly in power stations, we have a lot of transformers, generators, feeders, distributors, transmission lines. Lot of things are there on the distribution side also. And from production side, my electrical power manufacturing also, lot of equipments are there, right? Actually, for operating any valve or operating any doors or mill or any mobile equipment, we need power. So that very important. And even from control station, I mean, from the control room they are operating there, actually the smart electronics is there, where actually the electronics are playing a major role, right? Actually there we have instrumentation. Say instrumentation is mainly used for the, I mean, say for from the control room, actually they are operating through DCS, right? All the entire power stations, say the turbine, boiler, or say actually GT, everything will be controlled normally from DCS. And for, say for example, the coal mills or coal yard, and then actually electrostatic precipitators where ash are collected, right, deposited, and from where you are sending it to pond, right? Those things are actually operated with the local electrical equipment. Sometimes actually they are also controlled by PLCs, local programmer logic controls, or either directly from the DCS, because controlling from DCS actually is a heavy cost for those equipments, right? Actually, those are considered as unimportant, but again, actually, to maintain the vacuum, actually you need to maintain the proper level in the electrostatic precipitator. It should not be over damped. So if over damped, then actually it will disturb the boiler vacuum, right? Actually, so we need to properly maintain the ash level and everything, right? So that is a very important thing there. And so those are operated by the local operators or through PLCs and everything, say local automation. And if it like Gulf countries or some other US related kind of countries, right, Western countries, they are operating entire power plant through the DCS, PLCs, SCADA, supervisory control, data acquisition systems and everything. So actually even the generated power will be transmitted to the distribution center, and actually the immediate then and there the communication will happen. If any failure, it will immediately send the faulty trip message, and if it is unit is up, then it will send a continuous megawatt or the power total load. Actually, it will send all the data and everything. So from SCADA you can monitor central. You can it's a supervisory control, means it's a central repository or control systems from where actually you can take all the reports and everything. DCS is a distributed control systems where actually the boilers, turbines, and say different equipments, right? Actually in the power plant are easily controlled from the central control room, right? That is what DCS is used. And DCS will be these DCS are linked to the local control system through PLCs. That is also possible, or a SCADA kind of thing. So all these things are possible, and from the field actually they have a lot of temperature sensors, temperature transmitters, pressure sensors, and then actually we have level transmitters, level sensors, and then actually flow transmitters, flow sensors. So all these devices, local transmitters and sensors will send the data to the DCS, from where the control rooms, the persons can monitor the temperature, level, flow, say velocity, everything, right? Actually the pressure, everything. So can be easily monitored from the central display screen, so called actually, which is linked to these monitors are linked to the central computer monitors are linked to the distributed control system unit. Actually say each, they are calling actually say each unit actually, which is one is meant for boiler, and one is meant for turbine, one is meant for actually the electrical equipment control stations. Like that they will subdivide, and then actually we have lot of modules, and all these things are there. And actually these hardware are so called linked to the I can say the logical control unit, or where actually the ladder logic or instrumentation control logics can be implemented, and from where the instrumentation engineer can change the logic, and based on that actually this control room person can, based on the control room person's requirement, actually we can change the logic in the DCS control station. So this is normally done by the instrumentation. From instrumentation point of view, we have two aspects: local boiler instrumentation, and then boiler control instrumentation, turbine control instrumentation, or electrical related control instrumentations, coal yard related. So all these forms, I mean local pressure, temperature, velocity, pressure, all these sensors, right, transmitters, so called actually they are field instrumentation, and there you need I mean calibration and everything. Nowadays actually the engineering graduate is now nowhere required for field level control, where actually the polytechnic, I mean those who are doing a diploma, or say kind of I mean technical levels, right? Actually they can able to call ITI guys, right? Actually, so they can able to work on this field level field control instrumentation, right? Those who passed in diploma or ITI in electrical instrumentation or mechanical can do that. So mostly actually electrical guys will be deployed in instrumentation. And nowadays, due to modern instrumentation and control systems, supervisory control systems, so the very important aspect of instrumentation engineers is very important. And in case of second aspect is a supervisory or central control systems or distributed control systems, where a lot of logic, software related logics can be implemented. So the server say I can say this Windows 2003 server kind of actually the environment is required, server technology, right? Actually, so those kind of software related or firmware related actually control systems were involved. See that will help to monitor from the central distributed control system stations, so that actually you can control the entire power plant. So there you can implement this AND or NOT logic, right? Actually the logical gates. So all these instrumentation logics can be implemented through AND or NOT, this kind of logical or Boolean algebra, right? Actually whatever you are doing in engineering. So based on that they will frame the ladder diagram or DCS logic diagram, or PLC means it is a ladder diagram. So on off switches, say some temperature sensors, everything can be drawn through the ladder diagram. And in case of DCS we have lot of diagrams, actually say control and instrumentation circuits are there. So you need to monitor everything and control or change the logic. So if you want to, I mean if a particular valve is open, then actually the particular signal will reach DCS and it will give the some prerequisite condition to open the say firing of boiler. So these are the logics, actually say if you are doing this prerequisite condition, then subsequently the following conditions will happen, and Once that is happened, then the next consecutive actions will happen. That is what actually the first stage output will be given to the input as the second stage, and second stage output will be given to the third stage, and so on. Like that, actually, kind of closed loop control circuits were deployed in the power plant instrumentation. Not only power plant instrumentation, in any process control instrumentation, the same thing happens for maintaining the level, right, in a tank or a petrochemical instrumentation, whatever it may be actually. So instrumentation is very important actually nowadays. It is we cannot avoid instrumentation in any automated control systems. So the scope of instrumentation is good. Say in case of a turbine, actually the instrumentation will be used for capturing the temperature, stress, pressure in the steam temperature, pressure in the successive stages of turbine, when steam is passing from the first stage to the last stage and moving out to the say air cooled condenser, whatever it may be actually. So we have stress, temperature level, all these things actually. Say we need to maintain some friction removal, lubricants, everything. So all these things can be actually monitored by the instrumentation people. So connected with the sensors and transmitters, and from where it is connected to the sending the data to the distributed control systems. And in control system we have the PCs for boiler control, turbine control, the electrical level control. Like that, we have different monitor stations are there, and the say the control room person can sit from the central control station and monitor everything, right? So this is what actually happening in control system in power plant. Not only power plant, in any process plant, say aluminium or bauxite or whatever, actually the iron or anything, actually we have centralized control station from where actually you are monitoring the process, right? Actually, so if any defect, you are logging the defect in the shift log or something, from where actually the maintenance person will be checking the log on today basis, and then they will troubleshoot. They will take say whenever the permit is required, they will get the permission from the particular control room person, and then they will do maintenance. They will isolate the equipment first, or bypass the particular oil path or steam path or something with the approval of control room person, and then they will maintain the particular defect in the valve, and they will fix it, and then actually again they will be set in the used in process. So this is a daily process happening. Preventive maintenance, breakdown maintenance, all these things, right? Actually the plant maintenance activities there. So all this part of actually the power plant actually maintenance, that is called operation and maintenance, O&M, or simply they are calling. So all this instrumentation, electrical, mechanical, is a part of O&M, right? Actually, so no, nothing is actually isolated. So everything, mechanical, electrical, instrumentation are tightly integrated. So this is very important. So let me explain actually in my next videos. I will explain about the power plant instrumentation, applications, and whatever, what things will happen in day to day, how the boilers are controlled, how the turbines are controlled, or electrical circuits are controlled through the DCS or SCADA or PLC, right? I will even the conveyor, actually the coal conveyors or everything, right? It is controlled by the local PLCs, and from the PLC the signal will be sent to the DCS, open loop, right? Actually, say if any say we have proximity sensors, right? Actually, say if the particular conveyor is tilting, then the in the side, actually in the conveyor belt side, actually in both the sides we have the proximity sensor that will send a signal. Say this is very coming close to the sensor. It means actually it is the conveyor is slightly tilting or actually turning the path. Everything can be damaged or sagging. Everything can be monitored through the instrumentation sensors. And even the boiler, the water tube boilers, right? Actually, say we can easily check the internal conditions of the boilers, right? Through thermo resistance or water resistance cameras, which can be linked to the supervisory control stations. So everything will be monitored by the instrumentation. So So instrumentation application is really good. So this, I mean, instrumentation engineers will have a bright chance. There is no doubt in that. But getting into the field is very difficult. That is what I'm again trying to say that. Thanks for watching my videos. This is GV Shivkumar signing off. So we are going to see in the coming video in three parts, that is boiler instrumentation, turbine instrumentation, and say in accessories, unit instrumentation, right, like instrumentation control, where actually how the instrumentation is used in coal yard and mill, the conveyors, and then say for example electrical generation and transmission, all these things, right, air cooled conditions and motors, valves, right, actually we can see everyone in detail how the instrumentation is useful in many areas of power plant. So this is, I hope actually it will be a more interesting thing for you to understand how the instrumentation is important. So also we are subdividing field instrumentation into two: field level instrumentation and smart instrumentation, that is control room instrumentation or a distributed control system, SCADA or PLC kind of automation technologies, where instrumentation is mainly used. And apart from that, we have actually IoTs, and say artificial intelligence plays a major role in instrumentation, and how SAP is integrated with instrumentation, this DCS, PLCs and everything. So we can easily able to integrate this SAP with PLCs and SCADAs and DCS, right? So we will see everything in detail. So thanks again for watching my videos. This is GB Shivkumar signing off.